If your background is in the LAN environment, then you are used to the broadcast nature of Ethernet networks and the built-in features provided by broadcast multi-access networks. Frame relay networks are very different in operation. Broadcast networks afford you the ability for one-to-one communications, or unicast communication, one-to-many communication, or multicast, and one-to-all communication, or broadcast. Frame relay networks are non-broadcast multi-access networks, which means that they do not inherently include methods for multicast or broadcast communication. Now, in Ethernet networks, one of the primary uses of a broadcast is to dynamically map layer 3 addresses, or IP addresses, to layer 2 MAC addresses. This mechanism is called Address Resolution Protocol, or ARP. In frame relay, inverse ARP can be used to help to dynamically map layer 2 addresses, the data link connection identifier, or DLCs, to the layer 3 address. The difference is that layer 2 transport is not saturated with broadcasts. Instead, the frame relay router will send an inverse ARP request with its own layer 3 address and a DLC in the frame. When you see logical representations of frame relay networks, they tend to look similar to our diagram here. What's identified are the customer routers with the serial connections. What's a little more nebulous are the connections to the frame relay cloud. In actuality, we are identifying two device types in these topologies. One component is the frame relay router, or the data terminal equipment, also known as DTE, and the cloud represents the whole of the frame relay switching component, or the data communications equipment, also known as the DCE. So we know that DTEs are connected to DCEs, but how does the DTE communicate to the DCE, and what is it that's communicated? That is where the local management interface, or LMI, comes in. LMI is the DTE to DCE communication channel, and what it communicates are the status of connections or virtual circuits. When the DTE identifies the virtual circuit status, the DCE is able to communicate that status with other DTEs connected to the frame relay cloud. Locally, the frame relay router identifies virtual circuits with the data link connection identifier, or DLCI, which are essentially integers that identify channels available on the frame relay connection. It is the DLC that facilitates the DTE to DTE communication, or frame relay router to frame relay router, and can be equated to the Ethernet MAC address, as they are the identifier used to map to layer 3 addresses. It is important to note that frame relay encapsulates payload information in the frame, and by default, on Cisco devices, the encapsulation type is Cisco. If you run a multi-vendor environment, it is important that you change the default encapsulation to type IETF. When configuring your serial interfaces for frame relay operation, you have two interface types to choose from: multipoint or point-to-point. This becomes important when working to understand how layer 2 addresses map to layer 3 addresses. The physical interface is a multipoint interface. The sub-interfaces you define can be either multipoint or point-to-point. As mentioned earlier, a very important component to any layer 2 operation is the ability to map layer 2 addresses to layer 3 addresses. Inverse ARP is a dynamic mechanism that is enabled by default on Cisco frame relay operations. It will dynamically create the layer 2 to layer 3 mappings identified in the LMI communications to the frame relay switch. If you choose to disable inverse ARP or supersede inverse ARP operation, you can create static protocol mappings on the interface. If you need to support broadcast or multicast functionality, you must also add the broadcast keyword to your static mappings. By default, all virtual circuits configured on a device will live on the physical interface. In order to move the DLC to a sub-interface, you will need to statically map or assign the DLC to the sub-interface. On point-to-point sub-interfaces, there is only one DLC and one endpoint possible, so you use the frame relay interface DLC command. On multi-point sub-interfaces, you'll actually be pulling the DLC from the physical interface down to the sub-interface, And you do that with the mapping command. Frame relay map, you choose your protocol, which we haven't mentioned before. Could either be IP, could be IPv6, could be a bridging protocol. But this is where you apply what you're going to be mapping frame relay to. So the command is frame relay map, the protocol, the address used in that protocol, and then the DELSI. And of course, if you need to support broadcasts for dynamic IGP functionality, this is where you'll add the broadcast keyword. So when do we use the map statement? Here is a grid that shows your interface types and what command should be used in order to properly place the DELSI on the interface. For the main interfaces, you'll use the frame relay map command. For multi-point sub-interfaces, frame relay map. For point-to-point sub-interfaces, you'll use interface DELSI. On interfaces where you have point-to-point on one side of the DTE and the other side of the DTE is a multi-point, the multi-point side will obviously be the frame relay map command, while the point-to-point side will remain the frame relay interface DELSI command. Some verification and troubleshooting commands and what they'll provide you. The show frame relay map command will show all PVCs or virtual circuits that are mapped across and communicating over LMI. The show frame relay TVC command will show you all virtual circuits configured on your local device. And the debug frame relay packet command will show you all the frames associated with frame relay that are coming in and out of your box.